Greetings everybody to our next video on geometry of triangles. So in this particular problem we are given a diagram, and basically that diagram consists of two right triangles. And they tell us the value for one leg, and they tell us the value of the hypotenuse of one of the triangles, and then they give us a value that tells us that AD is going to be, so the line segment AD is going to be equal to the length of the line segment BD plus 6. And so probably the first point to start with is just to recall what the Pythagorean theorem actually says. So what the Pythagorean theorem tells us is that when we have a right triangle, and for this right triangle, suppose that the legs are labeled as A and B and the hypotenuse is going to be C, that we've got an algebraic relationship between those legs and the sides, and that relationship is really given by A squared plus B squared is equal to C squared. And so we can use that for both of the triangles that we are given in our diagram. So now coming back to the triangle that they gave us, we had one side say that's going to be x and that's going to be y. Well, for the big right triangle, we then have one leg, which is going to be x plus y squared, plus the other leg, 36 squared, is going to be equal to the hypotenuse, 60 squared. Well, 36 times 36, we can evaluate that. 60 times 60, we can evaluate that. And so we get x plus y squared is equal to our 1296 plus 1296 is equal to 3600. Well, we can move the numbers over to one side so that we get x plus y squared is just going to be 3600 minus 1296. And so that's going to give us a value of x plus y squared is going to be our 2304. Well, what we can do now to get rid of the square is just to take the square root of both sides. So if we take the square root of both sides, what we then find is just that x plus y is going to be equal to the square root of 2304, which is... So now what we're interested in this problem, or what they actually asked about, was what is going to be the length of this value x. So that's the thing that we're wanting. And so from there we need to take a look at what the relationship, the other relationship that they gave us regarding the hypotenuse for the smaller right triangle. So let's take a look at that problem again. So what we had in this picture was that we labeled this side between DB, we labeled that as Y. And so the side here, AD, they tell us that AD is going to be equal to the length of BD plus 6. Well, really, that's just Y plus 6. And so what that tells us is that hypotenuse is really going to have a value of Y plus 6. So now we can come back to our Pythagorean theorem and write down a second relationship between the legs of that smaller right triangle and the hypotenuse. So namely, that relationship, if we kind of label that original side as x again, that we get the relationship that x squared plus 36 squared is going to give us our hypotenuse, y plus 6 quantity squared. But then if we come back to the last slide and we remember what the expression was that we derived before, we had this value, so this relationship between x and y. And so really from the previous slide, we have that our equation x plus y was equal to 48. And so if we want to solve for y in that case, then we get y is going to be 48 minus x. What we're then able to do is to take that expression and substitute it in for y, to give us an equation x squared plus 36 squared is going to be 48 minus x plus 6 quantity squared. Well, we can combine that 48 and the 6 to give us a value of 54 minus x quantity squared over on the right-hand side. So now we're asked to solve the equation x squared plus 36 squared is equal to 54 minus x, quantity squared. Well, the 36 squared gives us a 1296. And then for the 54 minus x squared, we have to FOIL that out. So we've got a 54 times a 54, and a 54 times x, an x times 54, and an x times x. So over on the left, we've got x squared plus 1296, and then that's going to be equal to our 54 times 54 minus 54 times x minus another 54 times x, and then plus our x squared. Well, kind of combining like terms and simplifying things a little bit, we get x squared plus 1296 is going to be our 2916 minus 108x plus our x squared. Well, now we can subtract x squared on both sides, and so that's going to cancel out on the left, cancels out on the right to give us a 1296 equal to 2916 minus 108x. Well, now we can subtract our 2916 on both sides. And so if we do that, over on the left, we have our negative 1620, and that's going to be equal to our negative 108x. So kind of moving that over a little bit, giving us a little bit of room. We've got our negative 1620 equal to negative 108x, so we can divide both sides by our negative 108. And so what that's going to give us, we have our negative 108s canceling out, it's going to give us 15 is equal to x. And so the length of the side that we were interested in, our segment, was going to be 15. So it's a little bit involved. We had to use the Pythagorean Theorem a couple of times, but I hope this has been clear, and I will see you guys in the next video. Take care.